Okay, good afternoon, grade 11s. I hope that you're also excited to be here. We're going to do a little bit of trigonometry equations today because that's quite an important part and they are definitely going to ask you something similar next year. Now, the first question is find the general solution, or for all of them, I'm going to ask you to find the general solution. Now, there's a few types of equations, and if you know how to solve the different types, then it's really not difficult. Now I've started with three basic ones. 3 sine theta equals 2, 3 cos x equals minus 1, and a half tan theta is equal to minus 2. Now, before I start with them, you are going to work with a set of axes 0, 90, 180, 270, and 360. Quadrant 1, 2, 3, and 4. Can you remember we said yesterday you must draw this set of axes wherever you're busy with trigonometry. All students take chances. Now there's two ways of solving equations. Now I'm going to show you both and I'm going to tell you which one I prefer, but now I know a lot of you will use the other method, so I'm going to explain both. So the first one is if you have something like 3 sine theta is equal to 2. Okay, the first thing is you get sine theta alone. So you divide that 3 away. So you have 2 over 3. Now there's two methods, and I'm going to show you the two methods. Put up your hand if you're using the reference angle method. Okay, there's some of you. So I'm going to show you both methods. The one method is where you're first calculating reference angle. Now, that's the method that I don't like much because it's a lot of work and there's many places to make mistakes. But I'm going to show it to you and then I'm going to show you my method. For reference angle, you must just use the positive value there. Okay, the positive answer. So if it was a negative, you ignore it. So for reference angle, you say shift sign of 2/3 and you get a reference angle of 41,81 degrees. Okay, then you say, look at what they've given you. Now, in this case, they've given you that the answer is positive. There's a positive there. So now you say sine is positive in quadrants. So sine is positive. Why positive? Because that's what your sum says. In quadrant, now you go to your set of axes. Sine is positive in the first quadrant and in the second quadrant. So you say sine is positive in quadrant 1 and quadrant 2. And then you do two sums for the different quadrants. So now you must work in quadrant 1 and then you must work in quadrant 2. Okay. So, okay, in quadrant 1, it's easy. You just take the reference angle as it is. So whatever you have there behind the sign, so theta is equal to, and you just take your reference angle, 41,81. I've rounded off to 2 decimals. And you add 360 K, where K is an element of Z. I'll explain that just now. And for the second quadrant, you say this angle there, theta, is equal to. Now, what do you do to get an angle in the second quadrant? Like we said yesterday, you say 180 minus. Okay? Remember the 90 to 70 axis we don't want to work with because it's the bad axis. Then you must work with co-functions. So we're going to say for second quadrant, I must say the angle is equal to 180 minus, because I'm working in the second quadrant, the reference angle, which is 41,81. And for general solution, you also add 360k, where k is an element of z. Now the left-hand side is finished, and I just subtract there, and I get 138,19 plus 360k. Okay, why 360k? If you think of the sine graph, there's the sine graph, y equals sine x or sine theta. Now, can you remember the period means how many degrees does it take to make one complete wave? Now, there's one complete wave. I've drawn you one complete wave. So the period of the sine graph is 360 degrees. So that means if you look at the sum, where will sine be equal to 2/3? Now, there's 1. So 2/3 is more or less there. Okay. So it's at, and we calculated, the answer will be, let me take another color, 41,81 degrees. It's now there. Okay. And the other place where sine will be equal to 2/3 is at 138 degrees. So it's there. So that's the other value, 138,19 degrees. Now that's just two values. And those two values, or those two answers, are between 0 and 360 degrees. But you know that the sine graph doesn't stop. It just carries on, and it carries on to the left-hand side. So there's quite a few other values, well, infinite numbers to be exact, where you will also get an answer of 2/3. Can you see it will be there again? And it will be there again. And it will be there again. And it will be there again. So if I take my graph and I go 360 degrees further, in other words, one wave, I will get that answer there. And if I take that same answer and I go 360 degrees to the left, I will get this answer there. So that's exactly what general solution means. General solution means you want all the possible answers. Okay? And if you take this answer here and you go 360 degrees further, can you see you will find that value there? Or if you go 360 degrees to the left, you will get that answer there. So you must add or subtract 1 times 360 degrees, or 2 times 360 degrees, or 3 times, etc. If you go to the left, you add minus 1 times 360. Now you're going to the left. Or minus 2 times 360. Because remember what Z is. Z is the set of integers, means whole numbers. So it's 0, 1, 2, etc. But it's also minus 1, minus 2 to the left. Okay. So if you add or subtract one period, you get all the possible answers. And that is exactly what general solution is. Okay. Now I'm going to show you my method for this sum, and then you can decide which one is easier for you. sine theta is equal to 2/3. Now, I'm going to show you the three methods or the three different functions, sine, cos, and tan. And then I'm going to do both that you can decide. So if you want to get rid of sine, you just say, make two legs and somewhere in the where you divide, you say, I must remember that k is an element of z. And you just say, theta is equal to shift sine 2/3, your right hand side, plus 360k, or your other leg is theta is equal to 180 minus, and then shift sine 2/3 plus 360k. And you just simplify and you're done. You're done. So that will still give you the 41,81 plus 360k. And this one will give you 180 minus 41,81 plus 360k, which will still give you your 138,19. Now the difference is you don't have to find the reference angle first. And you don't have to look in which quadrants you have to work. For any sine sum, you can just do this. You say shift sine of the answer, or let me make it in red. Shift sine of the answer, or 180 minus shift sine of the answer. And then you add your 360k. And you just simplify. You just simplify. Now, if I go if I go to number 7, I'm going to do number 7 because it's a sine one as well. So if you use my method, I'm going to show you both. Then you say, okay, it's sine 2b minus 15 equals a half. You don't have to work with reference angles. You just simply say, okay, when I get rid of the sine, I just say, now there's my angle. There's my angle. So my angle 2b minus 15 is equal to, how do I get rid of sine? Shift sine of the answer. Shift sine of the answer. And you remember to add 360k. And remember k is an element of the integers. Or your angle is equal to, and what do you do with to get rid of sine? 180 minus shift sine, and your answer is a half. And you remember to add 360k, and you just simplify. You don't have to find reference angle. You don't have to look in which quadrants you are working. So if you simplify this, you're going to get a 30 here plus 360k. I'm just going to finish this side. So now I take the minus 15 to the other side. So 2b equals 30 plus 15. To get rid of the minus 15, you plus 15. So 30 plus 15 is 45 plus 360k. Now to get rid of this 2, you must divide by 2. So b equals, divide by 2. This will give you 22,5 degrees. Now, don't forget to divide here as well. You cannot discriminate, eh? So you divide here by 2 and you divide by 2 there. And there's your first leg finished. Now you do the same with the other side. Shift sine a half is still 30 degrees. So it's 180 minus 30. plus 360k. So that gives you 150 plus 360k. Now take away the minus 15 by adding it. So 2b is equal to 165 plus 360k. Divide by 2, divide by 2, divide by 2. So b equals 82,5 plus 180k. Okay. If you use your reference angle method and you're looking in which quadrants you must work, you are going to get the same answers. But for me, this is easier. Okay, now let's do a cos. Then I'll show you my method and I'll show you the reference angle method. 3 cos x equals minus 1. Let's do it, yeah? 3 cos x equals minus 1. Now let's do the reference angle method first. So you divide this 3 away to get cos x alone. So that gives you minus a third. Okay. Now, if you work with the reference angle method, you must say reference angle is equal to shift cos. But now you must remember to throw away the minus. You must just take the positive. So shift cos a third, because your reference angle is always an acute angle. So that will be 70,53 degrees. Now you say, okay, cos is, but now you have a negative there. So now you say cos is negative in quadrants. Now you go to, you go to your set of axes and you say, where's cos negative? Now cos is positive in the first quadrant and in the fourth quadrant. So cos is negative in quadrants 2 and 3. And remember, for quadrant 3, you say 180 minus theta. For quadrant 3, you say 180 plus theta. Okay, so let's do that. So cos is negative in quadrants 2 and 3. Now you must do a sum for quadrant 3, for quadrant 2, and you must do a sum for quadrant 3. So now you say, okay, I must remember k element of z again. Cos x.
Ma'am?
Yes.
Maybe please go at the back. What happened to the negative at the reference angle?
Yeah. Are you asking me what happened to the minus? Yeah.
Yes, ma'am.
Okay, that's what I'm saying. If you use the reference angle method, then you must work with a positive there. You must work with a positive. And then you say, okay, now I'm going back to the negative by saying cos is negative in quadrants 2 and 3. And now I'm fixing the sign again. Okay, so you're saying for quadrant 2, x is equal to shift cos, let me just, so x is equal to, now you take your reference angle in the second quadrant. Your reference angle in the second quadrant. So what do you do in the second quadrant? You say 180 minus, and now you take the reference angle, 70,53, and you add 360k again, because the period of the cos graph is 360 again. And if you simplify that, you get, Oh no, did I? Okay, there was a -1. Okay, so now I did it for +1. Let me just see my reference angle. So that will be 74901. Is that right? Plus 360K. Is that right? So this is my answer in the second quadrant. So I threw away the minus for the reference angle, but then I fixed it again by looking in which quadrant I'm working. Second quadrant, 180 minus, and then I do the same for the third quadrant. I say to get some angle in the third quadrant, I have to say 180 plus my reference angle. So now, where's my sum now? So I say 180 plus the reference angle plus 360K because I'm working with cos and the period is 360, and that will give me 250,73 plus 360K. But I'm now going to show you my method, and I think my method is easier. So to get rid of cos, doesn't matter what you have, to get rid of cos, if you have cos of an angle equals whatever you have there, to get rid of cos, you simply say theta,
Ma'am?
yes, I'm listening. Oh, sorry, there's a 5. That's
Ma'am?
what you wanted to say. Yes, I'm listening. Okay, are you okay? Now, if you use my method for cos, you don't work with a reference angle. You don't have to look at which quadrants you are working. You just say theta equals shift cos of whatever you have there plus 360K, K element of Z, or, and your second leg, you just simply say minus cos, shift cos, whatever you have there plus 360K. And I'm going to show you with my method. So let's take that sum again. So the sum was cos x equals minus a third Bushley, you can ask me.
Okay, ma'am. I wanted to ask on the table where there's Roman figure 2, the last answer that we got the 109,47. How do we get to that?
I subtracted 70,53 from 180. Now, how do I know I must subtract it from 180? Because they gave me the sum cos is negative. Cos equal to negative. Now, that's the point. If you want to get the reference angle, you must ignore that negative. But now you must fix it again by saying, okay, cos is negative in quadrants. And we saw that cos is negative in quadrants 2 and 3. And to work in quadrant 2, I must say 180 minus my reference angle. And to work in quadrant 3, I must say 180 plus my reference angle. But now, if you look at my sum that I'm going to do now, then you don't have to work with reference angle, and you don't have to look in which quadrants you must work. That's why I think it's easier. So all that you do is you say, okay, to get rid of cos, you make your two legs. You simply say x equals shift cos of whatever you have there plus 360k. Remember to add k element of z, otherwise you're going to lose a mark. Or, and now you just say x equals minus shift cos.
Ma'am,
Yes.
I have a question. When
Yes.
you're looking for the reference angle in your second method, wouldn't you like mix a Mac for the reference angle? Because in your method,
Okay, in the method that I like, you
yes.
don't use a reference angle.
Okay.
So
But
you
like, wouldn't you
cannot,
like lose marks?
you will not lose marks.
You have to like look for.
You will not
Okay.
lose marks. I'm going to show you that the answers will be the same. Okay.
Oh,
So my method, for me, it's easier because you don't have to work with reference angle. You don't have to find that. And then also, you don't have to look in which quadrants you have to work, because you have one method and that method works for all the cost problems. Okay.
okay.
So if I can carry on with this one, now I'm asking minus cos, minus cos, minus a third, and
Yeah.
yes.
Why is it minus cos?
Okay. The reason actually is, can you remember yesterday we said this angle is positive theta because this is the positive way of measuring, positive direction. If I go in the negative direction, the opposite direction, that same angle will be there, but it will be minus theta. So cos have the same value in the first quadrant and in the fourth quadrant, plus theta and minus theta, because cos is positive in the first and the fourth quadrant, first and the fourth quadrants. Okay, so that's how you can remember it. But I'm going to summarize it for you now again, if you want to use my method. But now you must use one method and stick to it. Okay, you mustn't get confused. So if I say minus shift cos minus a third, I'm going to get minus 70,53 degrees plus 360k. And you're done. Okay, sorry, this was 70,53 plus 360k. You're done. Now you're going to say, yeah, but something is wrong because there I have 180 plus I have 250,53 degrees. And here I have minus 70,53 degrees. Okay. But if you, now what have I done here? Weet nie of my, het jy 'n sakrekenaar? Is jy 'n sakrekenaar iewerster? Okay. Just let me, this angle is not right here. When I did the sum at home, I forgot to write the minus there. So that's what's wrong here. Let me just quickly fix it. Ja, ek dink nie werk nie. Scientific calculator, enigiets met sin kos dan. Let me see if I can use my cell phone. I didn't bring my calculator with me. I forgot. Let me just see, where's the calculator now? Okay. Ah. I don't know how to use my cell phone because I never use it for calculator. Minus a third. Just type in shift cos minus a third, please. Just type in shift cos minus a third and then you give me the answer. I think the 109.47 is right.
It's 109.
Let me try.
109.47.
Yes.
Okay,
It's
so
109.47.
okay, so it's correct. So this one is correct. Okay, so now here it was supposed to be a 109.47. 109.47. Okay, so can
Yeah.
you see your method with a reference angle and my method without the reference angle gives me exactly the same answer. Okay, and now the same here. I'm going to get minus 109.47. If I just say minus shift cos minus a third, I'm going to get minus 109. Now, if you take this, because now you see the two answers are not the same, or you think it's not the same. The one is 250.53, and this one is minus 109.47. But remember, what does general solution mean? If you add 1 times 360, 2 times 360, minus 1 times 360, you will get all the possible answers. Now, if you take this minus 109.47 and you add 360, what are you going to get? 250.53 plus 360k. And there you have the same answers again. Okay. So, and if you leave your answer here, if you leave the answer like this, it's fine. You will not be penalized because this answer and this answer is exactly the same answer. Okay, so can you see why I say I think my method is easier? You don't have to work with reference angle, so you don't have to forget to leave out the minus. You don't have to look in which quadrants you are working. You just simply say shift cos answer plus 360k or minus shift cos answer plus 360k. And you don't have to work with reference angle and you don't have to look in which quadrants you are working. Okay, do you see why I think it's easier? Now let's do the last one for 10. Okay, you can ask me. Valisa.
I wanted if you're using the top July or cos or fold hang on.
You're breaking up a little bit. Will you please ask me again? Just ask again. You're breaking up a little bit.
Melissa, come on.
Valisa, you can ask. And I see Sammy, you can also ask.
Okay, thank you, ma'am. Ma'am, on your method, the other side, it is too late, right? The other side you used cos and then negative 1/3. The other side you used negative cos. So I want to know the negative, do you use it with tan and sine, or is it only applicable when you're dealing with the cos ratio?
It's only for cos. It's only for cos. So for sine, I'm showing you again. For sine, my method says, and I will give you a summary now. For sine, if you don't work with a reference angle, you just say shift sine of the answer plus 360k or 180 minus shift sine answer plus 360k. That's the method for sine. The method for cos is shift cos answer plus 360k. Oh yeah, you have see it. Shift cos answer plus 360k or minus shift cos answer plus 360k. That's the method for cos. And it's always going to be like that. Always, always, always. If you see a cos, that's your method. Shift cos minus shift cos. Forget the reference angle, forget all the quadrants. You just say shift cos minus shift cos plus 360k. If we're done with the tan, I will give you a short summary. Then you will remember. Now the one with the tan is half tan theta is equal to minus 2. So let me do that one. Half tan theta is equal to minus 2. So what's the method? You get the ratio alone first. So tan theta is equal to minus 2. To get rid of the half here, you must divide by a half. Divide by a half is the same as 2 times by 2. So that gives you minus 4. Now again, if you want to work with reference angle, method, then you must leave out the minus there. You must ignore it. So you say the angle is equal to shift tan of 4. You must ignore the negative. And that will give you a reference angle of 75,96. And then you say, okay, but now it's wrong to leave out the sign. So now I must fix the sign again. So tan is negative. So you say tan is negative in quadrants. What did we say? Where's my set of axes? There it is. Tan is positive in quadrants 1 and 3. So tan is negative in quadrants 2 and 4. So you must say tan is negative in quadrants 2 and 4. And then you must do your sum for quadrant 2 and you must do your sum for quadrant 4. And now you say, okay, to get the angle in quadrant 2, I must say 180 minus the reference angle, which is 75,96, and then you plus 360k, which will give you a 104,04 plus 360k. And for quadrant 4, you say the angle is equal to 360 minus the reference angle again, plus 360k, and you minus, and you get 284,04 plus 360k.
Ma'am, I have a question.
Yes.
I thought tan was K180.
Okay. Now, you're actually right. But now, if you want to make 2 legs, then you still add 360. But I'm going to show you, I'm going to explain to you why both will work. There's the tan graph. Now say I have here minus 4. So say minus 4 was there. Say minus 4 is here. Minus 4, so it's there. So you have an angle there. And then you have an angle there. And then you have an angle there. And etc., etc., etc. So if you go from the first angle and you go 90 degrees further, not 90 degrees, 180 degrees further, you are going to get that answer. If you go 180 degrees further, you are going to get the same answer again, etc., etc. If you go 360 degrees further, you're just going to get that answer there. And if you're going from that one, 360 degrees further, you're going to get that one there. So whether you add 180k here or 180k there, both will give you all the different solutions. So that's why I don't even like this method. I'm going to show you how easy it is if you don't work with the reference angle and you don't work with the quadrants. The sum was tan theta is equal to -4. Now, if you remember that the period of tan is 180, you simply say tan, shift tan, whatever that answer is, plus 180k. And remember, k is an element of z, and you're done. That answer will be -75,96 plus 180k. And you're done. Because I'm going to show you now. Take your calculators. If you take this -75,96 and you're adding 180, take this answer and add 180, please. What do you get?
104,0.
104.04.
Can you see? There's the answer.
Mm.
Add 180
Yes.
again. Add 180 again.
284.04.
Look there.
184,04.
Can you see?
Yes.
Yes.
So
Yes.
with one, don't you think this is easier than what I've done here?
Yeah, it is.
Easy.
It is.
Okay. So I'm going to give you the summary for my method. And I promise you, you've seen now that you get the same answers. So you cannot be penalized. Okay. So you can write the summary. So if
Okay.
you to solve sine. Okay. So say I say sine theta is equal to, and I'm going to put a little star there. Because it doesn't matter what the answer is. Positive, negative, it doesn't matter. You make your two legs and you say theta is equal to shift sine of that answer plus 360k, where k is an element of z. You mustn't forget the k element of z because it's going to cost you a mark. Or theta is equal to 180 minus shift sine star plus 360k. Done and dusted. So you don't have to work with reference angle, you don't have to work with different quadrants. To solve, now you have cos something is equal to. How do you get rid of cos? You make your two legs, you say angle equals shift cos of the little whatever your answer is, plus 360k, or angle is equal to minus shift cos little star plus 360k. So cos is easy. Plus shift cos minus shift
Ma'am,
cos. Yes.
why on the sign do we start by 180, not minus side?
The cos one,
No, I mean the sign one.
the sine one.
Yeah, on the other side, is
Well,
theta is equals to 180. It is not
one,
minus sign.
it is 180 minus shift sign star. That's the method if you don't want to use the reference angle and the quadrant method. Then this is the
Why
method.
why are we starting by 180, not minus shift sign?
Okay, if you look at your set of axes again, where's your sine function? Positive. It's in the first quadrant, so it's just shift sign. And where's the other value? Where the sine value is positive? In the second quadrant. And how do you get any angle in the second quadrant? You say 180 minus for second quadrant. If you want to remember it like that, that's a good way to remember it.
Okay, thanks.
Okay, okay. So that's the method for sine. Shift sign, 180 minus shift sign, plus 360k. The method for cos, shift cos minus shift cos. And the method for tan, to solve tan. You just say theta is equal to shift tan, little star, and you just have to make one solution. You don't have to make two legs as long as you remember to add 180k, k element of z, because the tan function has a period of 180.
80.
Okay, so there it's in short. There's the summary. You solve sine, cos, and tan. Then you don't have to work with reference angles, and you don't have to find out in which quadrants you have to work. It's much easier. It's less. It gives you less room for mistakes. You don't make sign mistakes. You don't make quadrant mistakes. You don't by accident say 180 plus when you're supposed to say 180 minus, or 360 minus when you're supposed to say 180 plus. So it's actually much easier. Now let's do one or two more. Then you will get used to my method. Let's do, I have done number 7. Can you see now if I go back to number 7 with my method? You just say, there's the sum. Here's the sum. You just say, make your two legs. Say, there's the angle. Angle equals shift sign answer plus 360k. Or what's your other leg? Angle is equal to 180 minus shift sign plus 360, and you just solve. Let's look at number 8. I'm going to do number 8 here. Number 8 was, number 8 says 4 cos theta over 2 plus 10 is equal to minus 3. So we must get cos something alone. So cos theta over 2 plus 10 is equal to, and I must divide this 4 away. So I have minus 3 over 4. Now if I use my method, to get rid of cos, you make your two legs, somewhere right there, k element of z, then it's done. Then you're not going to lose that mark. How do you get rid of cos? You say angle. Now remember, this is your angle. So theta over 2 plus 10 is equal to, what do? Shift cos minus 3 over 4 plus 360k, or you take your angle, theta over 2 plus 10, and you say minus shift cos answer plus 360k. And now you just solve. I'm going to solve one at a time. So if you ask your calculator shift cos minus 3/4, you're going to get 138,59 plus 360k. Take the plus 10 away by subtracting. So theta/2 is subtract 10 from 138, then you get 128,59 plus 360k. Now get rid of the divide by 2 by saying multiply by 2. And if you multiply by 2, you get theta is equal to 257,18 plus. Now you've multiplied the 2 away the left-hand side. You've multiplied the 2 away there. You must also multiply the 2 away there. Otherwise, you're discriminating. So 360 times 2 will give you 720k. And now I'm going to do the same at the right-hand side. Now I have minus shift cos minus 3/4 will give me minus 138,59 plus 360k. To get rid of that plus 10, I must minus the 10 again. Now I get minus 148,59 plus 360k. To get rid of the divide by 2, I multiply the 2 away again, and I get minus 297,18. And remember to times the 360 by 2 as well, 720k. Now, the only difference between your answer and, or my answer and if you use the reference angle method is that you will get a positive answer, yeah. But now if you take this negative answer and you add 720, you're going to get that reference angle method answer. So everything is the same, nothing wrong. Okay, so that was a cos, another example of the cos. So let's take another example of tan. I'm going to do this number 9. So 3 tan 3x minus 30 minus 3 is equal to 0. You know that you must get tan of the angle alone. So I must take this minus 3 to the other side. Then I must divide this 3 away, which will give me a 1 here. It's tan. So if you remember to add 180k, you don't even have to make 2 legs. So you say angle, which is now 3x minus 30, equals shift tan of 1. Remember, if you only want to make 1 leg, you must remember to add 180k, k element of z. If you say shift tan 1, you're going to get 45 degrees. Oh, you don't have to write k element of z more than once in a sum. If you write it once, it's fine. It's just a habit that I have. Now I'm going to get rid of the minus 30, so I take it to the other side. So that becomes 45 plus 30 is 75 plus 180k. Now I must get rid of that 3, so I'm going to divide the 3 away. So x equals 25 degrees plus, and don't forget to divide the 180 by 3 again, so that will give you a 60K. And that 25 plus 60K will give you all the possible answers that you can find for this equation. Okay. Now what they can also ask you, they can give you the sum and say, now solve in a specific interval. In a specific interval. In other words, just give the answers between minus 360 and 0. Now what you're going to do is you're going to do the general solution first. You're in any case going to do the general solution. Okay, so let's do the general solution. 4 sine b plus 30 is equal to minus 3. Divide this 4 away. And now I can do my 2 legs. So my angle is b plus 30 equals, what's my method to get rid of sine? I say shift sine of the answer plus 360K, or what's the second leg for sine? The angle is equal to, what's the method? 180 minus 180 shift sine minus 3/4 plus 360K. I'm going to do my 2 legs. I'm just going to simplify. So that will give me an angle of minus 48,59 plus 360K. I'm just going to do the 1 leg at a time. To get rid of this plus 30, I must say minus 30. So minus 48 minus 30 give me minus 78,59 plus 360K. So there's my 1 leg finished. I'll go to the other leg. I will get minus. Now can you see there's a minus, there's the minus. Shift sign of minus 3/4 is minus 48,59 again. And then this minus and this minus will become a plus. So 180 plus 48,59 will give me 228,59 plus 360K. To get rid of this plus 30, I must minus. So this will give me 198,59 plus 360K. So now there's my general solution. But what are they asking me? They're asking me for the angles only between minus 360 and 0. So what do? I take my general solution and I say, okay, if I look at this one, if I look at my left-hand side, if I don't add 360K, in other words, I add 360 times 0, then I have an angle of, so I'm going to write it here, my possibilities. I'm so glad I'm not an English teacher. Possible angles. That minus 78,59 is there. If I subtract the 360, what am I going to get? If I subtract the 360, I'm going to get minus 438,51 or 5. 59. No, whatever, you can calculate that. Yeah, that's right. If I add a 360 to that angle, I get 281,41. Now let's look which angles here is in this interval. It's only this one here. Can you see? So I'm not interested in this one. I'm not interested in that one. Now I do the same for the other leg. If I add nothing, 0 times 360, I get 198,59. If I subtract a 360, what do I get? Minus 161,41. If I add a 360, well, can you see, you don't want any positive angles. So you don't even have to add. So this angle is in any case not going to work. This one is going to work. So now I just give all my possible answers. And the easiest way is to give it as a set of angles, make curly brackets, and you write all the angles in the set. So it will only be this minus 161,41, and it will be this minus 78,59. Okay, now unfortunately I prepared a lot of sums, but we didn't get time for that. So remember, the videos are available on the Ligbron e-learning, the Ligbron online school. So if you want to watch it again, you can just download it and watch it. And then tomorrow I'm going to do a little bit of analytical geometry, tomorrow and Monday. So see you tomorrow again, same time, same place. Keep well. See you tomorrow. Bye.